goes out to 5, 10, and this is starting at 0, 0. Just like the last problem, I'm going to take a typical slice, and when I cut and I look, it's a circle, so I've got that same basic setup of a pi r squared times my little dy thickness. But the radius isn't 5 all the time. So we have to be creative here and take a look at what happens to the radius. We know that if this is some ordered pair x, y, right? X represents the distance out, y represents the distance up. I need to know about that x value to get the radius. But the fact is, it's along this line, and this line, I can figure out that line's equation. It's got a slope of
2.
up 5 over 10, so it's got a slope of 2. And when I put that into our old y equals mx plus b business, my y-intercept was at 0. My slope was at 2, so I have a nice relationship between y and x that I can use. So the radius is x, but in terms of y's then, it looks like that. So now my work is going to be this force times the weight per unit, and he's got it in the problem. The oil is 57 pounds per cubic foot. And then
This is represented in feet, right?
yeah, this is the 2 was feet, the 5 was feet, or not the 2 is feet, the 2 is the slope, but this was 5 feet wide and 10 feet high. And in the problem, it's how much work to pump the oil to the rim of the tank. But wait a minute. How much to pump it to the rim?
The water only
But the
reaches to the 8.
the water only the oil only goes to 8. So
From 0 to 8.
this is from 0 to 8, but these slices have to be 10
That's why.
minus y.
Why?
It says in the problem that the oil only goes up 8 feet because it's 2 feet below the top, but we want to push the oil all the way to the top. So this slice is at some height y, this is some height y, and I need to go a total of 10, so what's left to move, this piece is 10 minus y. And then once again, F int. Go ahead, ask.
No, we were just thinking, I was tying it to like a
Different,
problem.
oh, hooray.
So I was just thinking,
Like what was it?
like when we were doing shell method, I was thinking about like when it was the 1.
Yeah, when it was constant versus when it varied, depending on where the other side of the shell.
Yeah.
Yeah. This part's very much like what we did with those shells when I was trying to make you measure. Okay, if this is the total part, and this is the x value, then this has got to be the total minus the x. Only now I'm up on the y-axis, so it's up y high. Yeah, it's the exact same thing as when we did the shells.
And the parameter or the I guess, are the same too. What do we call
Yes, from where to where
Yeah.
the limits of integration go from wherever the shell started to it ended. And this is the same thing here. The oil only started at the bottom and it quit 8 feet up. So yes, it's very much like our shells. Oh, thank you. That's a lovely relationship. And then the rest is effant. And so that was all I had.